Here's what fletching does. Fletching acts kind of like an air catching device of some kind. That's not good either. It's like
I'm not learning anything, Professor.
Just go read a book. Look it up on Wikipedia. Why do I have to keep telling you things?
Hello, boys and girls. For the goodness of science. Hello, boys and girls, and welcome to NSAPA, the National Sock and Person Administration. Our 5-year mission to explore strange new worlds and civilizations, to sell t-shirts, bumper stickers, and anything else we can think of, to boldly go where our budget will allow.
That is not our mission. And speaking of our budget, we would save a lot of money if we turn off all these lens flare generators. That's better.
What is our mission today?
Our mission is to get rockets to fly.
We've already done that.
We've got them propelled, but in order to truly fly, in order to land on the moon, they need a more stable path. Today, we take these self-propelled missiles and we turn them into space-worthy spacecraft.
The first thing we need to look at is football.
Football?
Trust me.
This is why I went into science.
For the first time I can see. Left my doubts in.
Do you see the difference between his throws and yours?
Yeah, his are good.
There are two key reasons for this. The first is rotational motion. By throwing what we call a spiral, meaning the ball rotates around a central axis that's aligned with its forward vector, the ball stays aligned on its trajectory because of its gyroscopic motion.
Ah, why didn't you say so?
You don't know what any of that means, do you?
Not a word.
It means this. Because it spins, it doesn't tumble.
Okay, that's what I thought it meant.
The next reason is the shape of the ball. The point is aerodynamic, and it helps keep the ball facing in the same direction.
So if we give the front end of our bottle a shape like that, it'll fly better.
Correct.
What else?
Consider archery.
This seems dangerous.
Now if we follow all safety protocol, to start with, let's fire some pencils.
That's a tape. Almost hit me in the face.
Here, try some meter sticks. As you can see, they're much longer.
Yeah, dude! Woo! Victory for science! So let's take a look at what we saw. Our arrows, as you can see, are fairly long. Our meter sticks are fairly long and both flew fairly straight. Our pencils are fairly short. When we let them go, what you saw was they flipped end over end like this, which is bad because there's so little mass around the center of gravity that it's easy to get it to rotate. For these things, they're so long that there's a lot of mass outside their center of gravity and it takes more effort to get them to spin. This is why when you see people walking on a tightrope, they're holding a really long stick, is because rotational inertia means that keeping something level is easier than getting it to rotate. The more mass there is outside of the center of gravity, the harder it is to get it to rotate. That's why long things, like our meter stick or like our arrows, fly straighter than something short like a pencil.
Yes, this is because of angular momentum. The mass of the meter stick, like any mass, resists moving. A mass spread out around a center of gravity will resist rotating, and thus stay more aligned to its trajectory.
So longer things are more resistant to spinning.
Yeah, basically.
Okay, so how do we apply this to our rockets?
We need to extend the rocket so the center of gravity is in front of the propulsion.
I know just the thing. If we attach an empty coffee creamer bottle to the front of our rocket, it'll have an aerodynamic nose cone and, because it's longer, a center of gravity in front of the propulsion.
But that bottle isn't empty. It'll be too heavy.
Well, I can fix that.
It's good coffee.
Now going to attach these two bottles together using our old friend duct tape.
No ducks were harmed in the making of this tape. Or this rocket.
Now, there's one more thing that we can add to help stabilize the flight. On arrows, they're called fletching. On rockets, they're called fins. The fins help stabilize the flight even more.
Time to hit the test platform.
Watch your float by as you innocently sigh. And she'll remind you that you're still alive. Sunlight's fading now, driving out of town. New beginnings waiting on.
When you try this at home, here's a couple of things for you to experiment with. First of all, how long do you need to make your rocket for the best stability? Secondly, does it help or hinder to add a little bit of weight to the front? Thirdly, what size fins and how many fins do you need for the best flight?
I am Professor Sockperson from NSAPA saying, good flying, cadets,
Shoot for the moon!
for the goodness of science.
Easy. To make green, all I have to do is mix blue and yellow. What? Oh. Hey, have you heard about the latest attempt by the Italian space program?
No, I have not.
They've decided to be the first to send astronauts to the sun.
The sun? Impossible.
Yeah, that's what they were told. During a press conference, the American reporter said, "Hey, the sun is so hot and bright, they'll be blinded before they arrive and vaporized before they can land." The director of the program said, "Yes, we've already considered that and have found a solution to those problems for the protection of our astronauts. We're going to send them at night."
Even though I foresee problems for this mission, I still don't think we should laugh at the Italian space program.
Come on, it's a joke.
At least they're trying.
Just say goodbye, Professor.
Goodbye, Professor.